Welcome to Exquisite. During the last two classes, we discussed extensively about two important points that have to do with curved mirrors. Those points were the center of curvatures, and the principal foci of curved mirrors.
Very true. You let me know that the center of curvature of a curved mirror is the same as the center of the sphere from which the mirror is sliced.
Correct. How about the principal focus?
You explain that the principal focus of a concave mirror is the point where rays that are parallel and close to the principal axis will converge after reflection on the mirror.
Great. I'm so proud of you. Now, in today's class, I want you to know something interesting which scientists have realized about the center of curvature and the principal focus.
Okay, Sensei. I am excited to learn about what it is.
Scientists have realized that the principal focus of any curved mirror is always midway between the center of curvature and the pole of the mirror.
That's interesting. Do you mean that, once I know where the center of curvature of any curved mirror is, then I can trace the principal focus to be the point midway between the center of curvature and the pole?
Exactly. And even the other way around. If you know where the principal focus is, then you can trace the center of curvature to be the point, twice away from the mirror.
Okay. This is really interesting.
Yes, it is. Scientists were also fascinated to realize this. In other words, we can say that the radius of curvature of a curved mirror is always twice the focal length of the same mirror.
Oh, I see. So, if the radius of curvature of a certain concave mirror is 50 centimeters, then its focal length will be 25 centimeters, which is half of that length.
Correct, Titi. Now that you know this, I want you to attempt this past university matriculation exam question.
Oh, I hope I get it.
The question says that the inside portion of part of a hollow metal sphere of diameter 20 centimeters is polished. The portion will therefore form a what? A. Concave mirror of focal length 5 centimeters. B. Concave mirror of focal length 10 centimeters. C. Convex mirror of focal length 5 centimeters. D. Convex mirror of focal length 20 centimeters.
Okay. First of all, since the inside portion of the sphere is polished, it means that the mirror is a concave mirror, and never a convex mirror. So, options C and D cannot be correct.
Okay, great move.
And now, since the diameter of the sphere is 20 centimeters, it means that the radius of the sphere is 10 centimeters. This is because we know from elementary geometry that the radius of a sphere is always half the diameter.
That's also correct.
It means that the radius of curvature of the mirror is also 10 centimeters. And therefore, the focal length of the mirror is 5 centimeters, which is half the radius of curvature. Option A is therefore the right option.
Good, that is correct. I especially love the way you got to the answer. You are such a genius.
Thank you, Sensei. And that is because you taught me well.
And also because you gave attention to all of the classes. Now, can you give a summary of something you learned from this class?
Yes, I learned that the principal focus of a curved mirror is always midway between the center of curvature and pole of the mirror. In other words, the radius of curvature is always twice the focal length.
Great. See you in the next class, where we will be looking at principles that enable us know how images of curved mirrors will appear.